teach you, okay, thank you. In the next 2 days, I'm going to teach you about 2 types of growth, 2 types of mathematical growth. The first type is called exponential growth, and this is the type of growth that you experienced in Algebra 2 with compound interest or radioactive decay. Those are exponential growth or exponential decay. And then tomorrow we'll learn about something called logistic growth and logistic decay, something that you probably, or many of you have learned about from your AP Bio class from Mrs. Aurora, when she talked about where you have a population whose growth rate starts off exponential, but eventually the population plateaus as the amount of the population starts to become, what do you call it, the environment, the resources of the environment become outstripped by the population, where the population can't grow anymore because the environment can only support a certain amount of this population. Did you guys learn that with Mrs. Aurora? Where the growth starts exponential but then plateaus out, levels off? That's called logistic growth, and we'll learn that tomorrow. But today is exponential growth, yes.
So does that mean when our Earth reaches maximum capacity, we'll start dying off?
Well, it depends. If we won't die off as long as things don't change. But if what happens, we reach a particular carrying capacity for the Earth, and then the environment changes, let's say due to global warming, suddenly you get all these diseases we didn't used to have, or due to global warming we stop being able to grow the food we used to grow, or due to global warming all these high population coastal areas get flooded, then you're going to see a decline in the population. You'll have a big die-off, Yeah, and that's, we'll talk about that tomorrow. Right? Even though, global warming is a hoax, global warming doesn't actually exist, except, the Earth is getting warmer and we're starting to experience that a little. But it doesn't exist. Remember, that's just a big hoax. Okay, but right now we got exponential growth. And whenever I say exponential growth, I always mean exponential growth or decay. Okay, exponential growth or decay. And so, from Algebra 2, and this is just intro right now, alrighty? From Algebra 2, you already dealt with this sort of thing, What if I told you, first example, bacteria, okay, it doubles every 3 minutes, and we start with 5. I got 5 bacteria, they double every 3 minutes. Can I have an equation that tells me how much bacteria I'm going to have in how many minutes? And the answer is yeah, sure. If I let y be the amount of bacteria, it ends up being like this. 5 times 2 raised to the power of t over 3. You actually dealt with this when you were in Algebra 2. This idea that when the time is 0, you got 5 bacteria. When the time is 3 minutes, then you'll have twice as much bacteria. When the time is 6 minutes, you'll have 4 times as much bacteria. And every 3 minutes, you'll notice if you plug into this equation, every 3 minutes the number of bacteria you have is going to double. 5, 10, 20, 40, 80, 160, etc. Another type of exponential growth you guys dealt with was compound interest. Let's say I earn 6% annually, but it's compounded quarterly. That is, it's compounded 4 times a year. And let's say we start with $100. Then many of you are going to recognize this. If the amount of money we have equals y, then this ends up being 100 times 1 plus 0.06 over 4 raised to the 4t power, where t is the number of years. This is saying, hey, in one year, I've gone 4 quarters and I increased my money by 1.5% each quarter. This is the same as 100 times 1.015 raised to the 4t. And so, yeah, if you're earning 6% a year, then you're earning 1.5% every quarter. And if t is the number of years, you got to multiply that by 4 to get the number of quarters. Like I say, you may remember this, okay? Or number 3.
Would you like a muffin or a cinnamon roll?
Cinnamon roll.
I'm sorry, for me?
Yeah.
Is this free?
Yes, it is.
Oh, sure, let me see what you got.
You want a cinnamon roll?
My goodness, what did I do to
You
deserve
can have a
this?
full or half or mix and match. They have anything on this trip.
Full or half? I'll take half of a chocolate muffin. Thank you very much. Wow, who's this from?
ASB.
ASB, I love ASB. Tell us ASB I love each and every one of them.
Have a good day.
Me too. I feel very cared for. I was just gonna phone it in today. I was just gonna tell you, I'm too tired to teach. Just sit and do nothing. But now that I got that half muffin, that changed everything. So cool. Alrighty, let's keep going. Or number 3, let's say 12% of whales die off each year. Okay, poor little baby whales. And so let's say you start with 5,000. Then the way you dealt with this in Algebra 2, if the number of whales was equal to y, then you'd say y is 5,000 times something raised to the t power, where t is the number of years. But I wonder if anyone can tell me, if I'm losing 12% of my whales every year, what number ends up going there? Yeah, good for you, 0.88. Because if I'm losing 12%, I'm keeping 88%. So I'm going to keep 88% of these whales year after year. Okay, this is what you did in Algebra 2. Well, now in calculus, okay, we're going to deal with another situation. But let me ask you this question. Name of these guys, which quantity has a rate of change that's proportional to the amount you have? That is, do any of these quantities have this property that the amount you gain or lose is proportional to the amount you presently have? Like, think about the money. Is the amount of money you gain proportional to the amount of money you have? Like, if you have twice as much money, then you're going to gain twice as much money?
Isn't that all of them?
Andrew says all of them. Does anyone agree with him that that's true for all of them? Okay, Zach agrees, Leilani agrees. That's good enough. I think if, the Bible says if 2 or more people agree on something, it's probably true. I think it's what the Bible says, doesn't it? Or if 2 or more ask of God, he'll be granted. Something like that.
Oh, well, I mean.
Yeah, that's what the Bible actually says. But I always like to think of it if 2 or more people agree on something in a math class, it's probably true.
Oh, math
That's what the
class.
Bible says.
Well,
Yeah.
sometimes
So-
all of them but one are wrong.
Yeah, true. Oh yeah, but here, yeah, okay, and I just want you to see that the rate of change is proportional to how much you have in all of them. If you've got 80 bacteria, then you're going to gain 80 bacteria in 3 minutes. If you've got 160 bacteria, then you'll gain 160 bacteria in the next 3 minutes. You see how the amount of bacteria you gain is proportional to the amount you have? If you've only got 5 bacteria, then in 3 minutes you'll only gain 5. The amount you gain is proportional to the amount you have. Same with the money, and same with the little baby whales, right? The more whales you got, the more whales are going to die off, If I've only got 500 whales, then I'm only going to lose, 12% of that 500 instead of 12% of 5,000. Okay, so let me just say that in words, okay? On each, okay, the rate of change of the quantity is proportional to the amount of the quantity. The rate of change is proportional to the amount. And so we can express that as a differential equation. dy dt, that's the rate of change of y. Rate of change of y is dy dt, and I'm going to say it's proportional to, so that gets me a constant of proportionality, which will be k, and it's proportional to the quantity itself. Dy dt equals ky. I am now going to solve this differential equation, okay? I'm going to say let y equal y naught when t equals 0. That is, I'm saying the initial value of this quantity, whether it's bacteria or money or baby whales, the initial value, the initial quantity, I'll call y naught. I'm now going to separate the variables. So I get dy over y equals k times dt. Then I'm going to take the antiderivative of both sides. And I end up with the log natural of the absolute value of y equals kt plus the constant of integration. And now I'm going to take e to the power of both sides of this equation. And e to the log natural of y power gets me just y. And I can dispense with the absolute value because e to the kt plus c is never negative. And then finally, I'm going to do this trick that I actually showed you once, and I'm going to do it again. Instead of e to the kt plus c, I'm going to call this e to the c times e to the kt. Are you okay that that's one of the rules of exponents that I get to do? And now, e to the c, since I don't know what c is, I can just call e to the c c, you know? I mean, that changes what c is, but it's not going to change my equation. E to the c, I don't know what it is, so I'll just call it c. So I'm going to rewrite this, y equals c e to the kt. And this is a technique you'll see a lot, where e to the c, you just rewrite as c. And now I'm going to plug in my initial condition. Okay, my initial condition says that when t is equal to 0, y is equal to y naught. So I get y equal c times e to the 0 power.
1.
Or let me just put this, yeah, here. Y of 0 equals c e naught. Okay. And then y of 0 is equal to y naught, and c times e is c. So I now found my constant. It's not the constant of integration. That's the constant of integration. It's just the constant for this equation. And so y naught is equal to c. So I get to rewrite my answer. I'm going to put it over here. Well, I'll put it over here. Y equals y naught e to the kt. All right? And so we're going to see this over and over again, that dy dt equaling ky is the same as saying y equals y naught e to the kt. To solve this differential equation, you always end up with that answer. So hey, let's do an example. I'm going to have to change your homework a little bit because we're not going to get all the way through exponential growth, but that's okay because I've got plenty of problems for you to do tonight. It's going to be just practicing integration by parts and u substitution. Here comes example number 1. Okay. I got $800 in an account, earns 6.3% annual interest. $800 in an account earns 6.3% annual interest. How much after 8 years if A, compounded quarterly, that is, every 3 months, they calculate how much money you gain. So every quarter of the year, they cut that percentage to 1/4 and say, okay, for this quarter of the year, you're gonna earn 1/4 of 6.3%. And they do that 4 times during the course of a year. And that's called compound interest. And you earn more money because during the course of the year, now you're earning interest on the interest that you've already earned. As opposed to simple interest, where they just did calculate it once a year, how much you earn. And so during that entire year, you're not making any money on any of the interest you would have earned during that year. But anyway, compounded quarterly. This is going to be y equals 800 times 1 plus the interest rate 0.063 divided by 4 raised to the 32 power. And so I get y equaling $1,319.07. That's how much you would earn in 8 years if your money was compounded quarterly. But what if it was compounded continuously? What if they didn't calculate your interest every 3 months and add it into your bank account, and thus you earn interest on your interest? What if they didn't even calculate your interest every day and add it to your bank account, and then for the rest of the year you'll be able to earn interest on whatever money they just dumped into your bank account? What if they compounded continuously?
Every second?
Yeah, every moment. Compounded continuously. They do it every moment. Well, now what happens is your rate of change, your instantaneous rate of change of your money with respect to time every moment is going to be 6.3% of whatever your money is, 6.063y. And we know from what I did here, I don't have to solve that differential equation. I already know what the solution is going to look like. It's going to end up being y naught e to the kt. And so this solution is going to be y equals, how much did I start with, $800? E to the 0.063t. And so y of 8 is going to be 800 times e to the 0.063 times 8. And so my money ends up being $1,324.26. So yeah, you earn $5 more over the course of 8 years. Of course, that's why banks don't compound continuously, because the fact is there's just not much difference between compounding continuously or compounding quarterly. So most banks compound daily. They just compound 360 times a year. You know? They don't even do it 365, I don't think. They do it 360 times a year because it's so close. But anyway, this is the sort of thing we'll do in earnest tomorrow. Let me just say for now, I don't, maybe you can do a couple of these problems, but I don't know. It's probably just easier for me to assign it all at